Okay. Good evening.
Good evening.
Okay. Today we are looking at mechanical, electrical, and plumbing. How to model mechanical, electrical, and plumbing. Can you see my screen?
Sir,
Yes, sir.
so I want to ask, the structures, you are done with it?
We've only done introduction.
Okay.
We've also done only introduction to architecture. Now, I want to come back and then do introduction to mechanical, electrical, and plumbing also, so that at least we have a fair idea of how each one is done. Now, you go back to each of them and then look at how to edit each of them and then detail them.
Okay. Okay.
So at least I want us to get a fair idea of what can be done in Revit. So today we are looking at mechanical, electrical, and plumbing. If I go to the systems menu at the top here, you see there's a systems menu here. You see we have HVAC. Let me bring my magnifier. On the systems menu here, we have HVAC for heating, ventilation and air conditioning, fabrication, MEP detailing, P&ID collaboration, mechanical, plumbing and piping, electrical, and then you have the model components, loadable components. There's one thing I want you to take note of. When we talk of MEP, we group all of them as building services. Building services. And when you say building services, we are assuming that you've put out the structure of the building already. You've erected and put up your walls, your windows, your roofing, your floors, your stairs, and everything. The building is complete. Then you bring in the services people. They are supposed to put in, we call it systems, into the building. If you want to, sorry. If you want to bring in water into the building, there must be a way for you to bring in the water from a source. The source can be the main Ghana water lines, whereby you connect a pipe and then bring the water from the main Ghana water line and then bring it into the building. Or it can be a poly tank somewhere that is storing the water that you can connect. It can be a borehole that you can dig and then put a machine on top and connect to the building and then bring in the water. So there might be one source of supply to the water, supply of water into the building. And when that water comes, you must find ways and means of distributing the water to any place where you can find the water. And normally, the water terminates at what you call terminals, where you get access to the water. And they're usually called taps, okay, or shower heads. So when you open a tap, then the water will come. When you open a tap on a second kitchen sink, you get water. When you open a tap in a bathroom, you get water. When you open a tap in the WC, you get water. So it's about you supplying the water to where it is needed. And the main medium that you use to supply the water to the building we use what you call pipes. So the water must pass through the pipes. Depending upon the size of the building, the pipes that is going to supply the water can vary. It can be small pipe, it can be big pipe, depending upon the volume of water that you need to distribute into the building. So the most important thing that I want you to understand today with regard to building services will be how to draw pipes and understand how to draw pipes when it comes to plumbing. I won't go into detail, just how to draw pipes. Now, when we talk of electricals also, to be able to pass electricals, you need to pass what we call conduits within the building. Normally, we use pipes to pass the conduits, and that is where the pipe cables will pass. So you should be able to draw the conduits very well. And now with electrical also, you also take the main power from the source of the power supply. Whether you are using the main electricity lines, whether you are using solar panels, whether you are using generator, you must first get the source of power before. If you bring it in, if you're using the main electricity lines, then the power must pass through a meter. From a meter, it will go to the main board. From the main board, then you distribute it to various rooms. That is, you can distribute the electrical to lighting systems. You can give it to the power systems. You can give it to camera systems, surveillance systems, alarm system, anything that requires electricity. When you bring in the power, you must find ways and means of distributing the power to wherever it is needed, either for lighting purposes, for alarm purposes, for acoustic purposes, for whatever purpose. And in this case, you should be able to draw your pipes clearly to the point where you need these things. And at the end of the day, wherever the pipes will terminate, wherever you pass your cables, where it will terminate in either a light, or it will terminate in a switch, or it will terminate in a socket. So you must know where your sockets and your switches are going to be placed so that you can pass your wires, your cables to where they need them, and should be able to do the connections in such a way that when you switch a particular switch on, a particular light or group of lights can go on or off. When you switch a particular a socket on, you can get power in it or not. That is what should concern us. When it comes to heating, ventilation, and air conditioning also, with that one, you are supplying either heat to the building or you are supplying cold air into the building. And that cold air must pass through what you call a duct. So with the duct, with the cold air that is coming, you must know the spaces whereby you are going to supply the air to. Either it is cold air or whether it is what? Hot air. So you should be able to draw the pipes carefully. And when you have a duct, when you're able to draw the duct and then direct the duct to the spaces where they are needed, then you can easily connect what you call terminals to the duct. That will supply either cold air or either what? Hot air into the space. Any question with this brief? Before I do the demo, any question? Hello, can you hear me?
Yes, sir.
Any question?
No question, sir.
So I can continue.
Yeah.
Okay. Now, when I want to draw a duct or a pipe or whatever, for now, let me open one of the system drawings, or let me just open the coordination drawing. Let's say level 1 working drawing. Or better still, let me go to 3D so that we don't get confused. Okay. I'll delete the scope boxes. I don't need them for now. So I'm in a 3D view. So anything that I want to draw, I can draw it here. So I'll pick first a duct. When I pick a duct, there are types of ducts that I can choose from the type selector here. If you look at it, we have oval ducts, we have rectangular ducts, then we have round ducts. There are 3 default families of ducts. You cannot add to the list, you cannot subtract from the list. Either it is a round duct, circular, or a rectangular duct, or oval duct. So let me pick, say, a rectangular duct, for instance, and then draw it. As soon as I pick the duct, before I draw, on the options bar, I might decide on which level I am drawing it. I have not created any level of my own, so there is the default level of level 1 and level 2. So I can decide whether I want to draw it on level 1 or whether I want to draw it on level 2. That's the first thing. 2, you might determine the size of the duct, the width of the duct. There are default sizes, as you can see, and then the height of the duct. Then the elevation of the duct relative to the level. Hello. Nixon. Hey, today they might cough.
Yes, that's some water.
Yeah, why don't you get some water?
It's okay, I'll manage. Water is not nearby. So when you come in here, you can specify the elevation that you want to draw the duct relative to the level that you are on. So currently I'm on level 1. The middle elevation of the duct is 2,750. So when I draw my duct here, this is a streak that I'm drawing. I'll end it at a point. What it means is that when I go to the elevations, any of the elevations, let's say, let me still do it in 3D, I beg. In 3D like this one, you see that the duct is 202,750 above level 1, as you can see here. So the reference level is level 1, and then the middle elevation is 2,750. I'll explain the middle elevation later on, but for now, let's assume that it's taken from the middle, because the elevation can be taken from the bottom or the top or the middle, but I'm taking it from the middle currently by default. And it is 2,750 relative to the level. If I change it to 0, what it means is that the duct will be at elevation of 0, that is exactly on the level. If I give it a negative value, negative 600, which means that the duct will go below the what? Level. And you can always change the level. Currently, the reference level that we have here is L1. So if I change it to L2, then it means that the duct will be relative to L2, but still at the same location. But you have to look at the elevation here, the middle elevation, relative to the L2. It is now negative 4,200. So if I make a positive 4,200, then what it means is that it will go to the top of the level above it by 4,200. If I change it to 600, or let's say 1,002, then it will be 1,002 above the level. That is the now I made it 200. I can make it 1,002, and it will be 1,002 above the level. That is what you need to know. If you see, there's also a start elevation, and then there's also an end elevation. So if the start elevation is 1,002, and then the end elevation too, I make it a different value. Let's say 600. then it means that the duct is going to slope because here is 600 and then here is what? 1,002. And then the slope will be defined. If I want to change the slope to say 10 degrees, I can change the slope also to 10 degrees. And when the slope changes to 10 degrees, I know the base value here, then I know the top value here. So depending upon what you want to achieve, one, you need to know the offset at one point, or the offset at the other end point, or the slope. If it is vertical, let's say 1,002 by 1,002, then what it means is that the slope is going to be 0. And when the slope is 0, it means that the slope is not going to be defined. Any question? Mr. Godwin,
Am I going?
today we are in your headquarters. So
Yeah, sorry I'm late.
okay, we are looking at how to draw ducts and then mechanical duct, plumbing pipes, and then electrical cables today and conduits. But we are starting with ducts in the first place. So what I wanted to find out is if, where's my screen? What I wanted to find out was that if you are drawing any object, whether it is a duct or a pipe or a cable trail, that object that you are drawing is always related to a level. So this duct, for instance, that I have here, this duct is related to the level L2, which is this level L2. And it has an it has an offset. It has an offset relative to the level also. And the current offset is 1,200, as we can see here. So 1,002, 1,002. Now, the start offset and then the end offset can be defined separately. So I can decide that the end offset here is say 0. And when I say the end offset is 0, then it means that the start offset is 1,002 and the end offset is 0, which gives us a slope. And by the length of it, the current slope is about 16.2162%. You can select it and then change it to say 10%. If you want to do degrees, you can do that. You look at it later on. And you can always define the start value and then the end value. That's what I'm asking. And I'm asking whether you are okay.
Yeah, I'm okay.
You're okay. Good. Let me go back to the 3D view again. Not only that, if you take a pipe also, it also has the same behavior like a duct. Before, sorry. Before I draw the pipe, I must also be sure the level on which I am drawing the pipe, either level 1 or level 2, because that is the default levels I have here. And then I might decide on the diameter of the pipe because I'm using standard pipe here. If you come to the pipe drop down, almost all pipes are circular. I've never seen a square pipe before. So I'm using a standard pipe. And if you look at it, you can define the diameter of the pipe from 6 mm, as you can see, through 8 mm, 10 mm, up to 200 mm. These settings, later on, you can vary them. Then you can specify your own settings of pipe sizes that you want to work with. But always, there will be a list of pipe sizes that you can choose from. Then 2, you must define the elevation of the pipe relative to the level on which you want to draw it. That elevation can always be on the level that is 0, above the level with a positive number, say 600, or below the level with a negative number, say negative 1,200. Okay, so if I do negative 1,200 and I draw my pipe right now, what it means is that this pipe that I've drawn will have an elevation of negative 1,200 relative to the level. If I look at it from the front, you see that the pipe is at negative 1,200 below the what? Below the level. Are you okay? Are you okay?
Yes.
You're okay. Now, if I select the same pipe, I can change the level on which it is associated with from the properties. Currently, the reference level is level 1. I can change it to level 2. As soon as I change it to level 2, it means that the reference level is level 2, and then the elevation is negative 4,800 relative to level what? Level 2. So if I give it a positive value, let's say positive 4,800, then it is going to rise above level 2 by a value of what? 4,800. I can change it to 3,000. Then to be above the level by 3 what? 3,000. I can change it to 300. Then to be above the level by margin of what? 300. That is in principle, that is what you need to understand about pipes, ducts, conduits, and cable trays. So let me go to another 3D direction again, and then I'll pick a conduit. If I pick a conduit also, the conduit also must have a level on which it is. You must specify the diameter of the conduit. Then you must also specify the elevation of the conduit. Then when you are done, then you can draw your conduit also. So this one becomes a conduit. You are seeing them as line work. They are actually not line work because the detail level is medium. When I change the detail level to fine, you see them as proper pipe, okay? Or as a proper what? Conduit. And this conduit will have a length and it will have an elevation, middle elevation, which you can always change if you want to. You can change the level, you can always change the elevation. The next one is cable tray. If you pick a cable tray also, that one to the same principle, the same concept, the level on which it is, the width of the cable trail, the height of the cable trail, the middle elevation, then you can draw your cable trail this way. So I've drawn a pipe, I've drawn a duct, I have drawn conduit, then I've drawn cable trail. Any question before I move on? Hello?
Exactly. That's not good.
You're okay? Okay.
The electric part.
Who is speaking? I didn't hear you well. Was somebody speaking? Hello? Everybody's okay. Hello?
Yes, sir.
You're okay.
Yes, please.
So I can move on.
Yes, sir.
Okay. Now, what I want you to understand is this one. at the manufacturer's level, pipes comes with a fixed length in terms of manufacturing. I think the longest pipe that you can get is about 6 meters. The longest pipe that you can get at any point in time is about 6 meters. Can I be corrected?
Yeah, you are correct.
6 meters.
Yeah.
You cannot get a pipe which is longer than 6 meters. So, if you are in Revit and you are drawing pipe, excuse me to say, you cannot draw a pipe length of about, say, 15 meters and assume everything is all right if you are drawing. No, you can't do that. So if you want to get a 15-meter long pipe, what do you need or what do you do?
You join.
You need joints. Okay, good.
Yes, sir.
The same thing is applicable to conduits, ducts, pipes, and then cable trays also. The same thing. This brings the next issue of what we call fittings. Fittings. And when I say fittings, I mean duct fittings, pipe fittings, and then conduit fittings. And Revit comes with a lot of fittings for the pipe. You must know the appropriate fittings to use. Let me go back to the libraries and show you something. Say, for instance, I'll go to insert, go to load family. Then within the load family, I'll go to libraries, English, UK. Then look for pipe. Then I open pipe. Within the pipes, we have accessories, we have valves, we have fittings. Let's discuss fittings first. So I'll go to fittings. Within the fittings, we have galvanized malleable iron fittings, malleable iron, ductile iron, cast iron, carbon steel, steel flanges, stainless steel, copper, stainless steel, mild steel, carbon steel, ABS, and then PVC, generic, HDPE, and then profiles. Let me take PVC for instance, and then open PVC fittings. So, solvent welded folder. We have brush reducing plane, cap plane, cross plane, elbow plane, socket plane, T-plane, and then T-branch. These are all different types of PVC fittings. Let me go up again to another folder and talk of, say, copper. We have brace, press fit, and then soldered. Let me open the press fit. Within the press fit, we have coupling press fit, coupling straight reducing press fit, cross press fit, crossover press fit, elbow press fit, elbow back plate press fit. Now, the point I am making is this one. Whichever pipe you want to work with and deal with, Revit only knows how to draw a pipe. But any pipe that you want to create, in terms of the type of pipe you want to create, is defined by the type of fittings that is applied to the pipe. Or is defined by the type of fittings that is applied to the ducts. Or it is defined by the type of fitting that is applied to the conduit. Or the type of fittings that is applied to the cable tray. If you do not assign fittings to them, you cannot draw them properly. For instance, if I take this pipe, right click, and then create similar, then I pick, say here, and then draw pipe in the middle here, it will automatically add a fitting there for me here, which is a T fitting, MT fitting. And this one is called a generic fitting. It's just a sample. It doesn't mean anything critical. You can't say it is PVC. You can't say it is a cast iron. You can't say it's a metallic fitting or whatever. This is just a generic fitting. Now, when I select the same pipe and then create similar, again, let's say from here, and this time around, I choose a different type. Let's say PVC. And then I draw from here to here. Okay. And then I try to connect another pipe to it from here to say there. What the fitting that to be placed there? Okay. The fitting that is placed there is a PVC what? Fitting, as you can see. And this one is a standard fitting. Let me draw another one again. Create similar. This time around, I'll take another type of pipe. I'll not take PVC. I'll take, say, chilled water. And with the chilled water too, I can draw a pipe from here to here. And when I connect another pipe to it at a junction here, let me see the type of fitting that will come. This one is also a different fitting. And if you look at it, this fitting here, as you can see, this fitting here, as you can see, and then this fitting here, as you can see, they are all different what? Fittings. Any question before I continue? Mr. Godwin,
Yeah, my kind.
do you get a picture I'm painting?
Yes.
Are you okay?
Yeah, I'm okay.
Thank you.
Yeah,
At any point in time, before you sit behind any PC and draw any pipe,
sir.
draw, yes, sir.
Uh, you see the PVC joint,
Mhm,
the PVC pipe.
mhm.
Can you use this joint for a different type of pipe?
Is that
Different
what?
joint.
Come again.
A PVC pipe uses a PVC joint, right?
I better speak out a bit. I can't hear you well.
Okay, I was saying a PVC pipe uses a PVC joint.
Uh-huh.
Can you use that same PVC joint for a different type of pipe?
Your question is not clear still.
Okay. I'm saying since PVC pipe uses PVC joints,
It uses PVC fittings. Uh-huh.
yeah. Can you use that same type for um, a different pipe, but not for PVC?
No.
It's not possible.
PVC pipe or PVC plumbing is different from, let's say, PPR plumbing, and it's different from, let's say, copper pipe plumbing, and it's different from, let's say, metallic plumbing. If you go to oil refinery, let's say Tema oil refinery, the pipe they use there, the fitting they use there is totally different from if you go to, let's say, Abuasi gas plant, Abuasi thermal gas plant. The pipes and fittings they use for gases are also different. So depending upon the kind of system you want to create, then you need to choose the appropriate fittings for that purpose. If you go to any hardware shop where they sell especially pipe accessories, you can get different type of fittings for pipes. So there are so many of them of different sizes, of different types. We have T's, we have bends, we have cross, we have whatever. So you need to buy those series before you can work with them. So in Revit 2, if you want to work with a particular type of pipe, then you must make sure you have the library of fittings for that particular type of what of pipe. Is your question answered?
Yes, please.
Mm.
Yes,
Okay.
please, I understand.
You understand?
Yes, I'm okay.
Okay.
Yes.
Now, you see, this is a PVC. When I select it and I create another one as a bend, let's say 90 degrees. 90 degrees, as you can see here. It will add another fitting for me. And this one, we call it a 90 degrees bend. Okay. If I take it and then draw another pipe, create similar, let's say from the middle here, and I go at an angle of say 45 degrees here, it will create another bend for me, which is 45 degrees. These are standard fittings. You cannot add to the list. You cannot subtract from the list. These are manufacturer agreed fittings that meet standards and protocols. So the only thing you can do is to know which type of fitting you want to use, adopt it, and then use it. As simple as that. If I go to cable trays also, conduit also have their own fittings. When I want to create similar, and I connect it to the middle here, watch closely, and I add it at 90 degrees. See the kind of fitting it added. This is a conduit fitting. And when you select it, it will give you the name. We call it junction box T. This one is what you call a junction box. So you must understand the vocabulary of conduit fittings before you attempt working with what? Conduit. If I take this one and then create similar at the end at an angle of 90 degrees, just a bend of it, let's see what I'll get. I'll get a bend here, which is called, if you hover over it, you see the name. Okay, it's called conduit elbow. Conduit elbow, play and PVC standard. When I select this one, then I click on this plus sign to get a T. It will give me a T1, then I can draw another pipe in that direction. If I come to this duct here, let me put it at the same height for now. 1,200 height. As soon as I create similar, also from the middle, and then go this way. It will also add its own fitting to it. And when you select it, you see that there's a fitting and it has a name. M rectangular T standard. Which means that there can be another fitting, which is T for duct, but it will necessarily not be a standard one. If I go to the type selector, you can have different T's, oval T, rectangular T, and then round T. So if I pick another duct, for instance, create similar, and then I choose, for instance, over tabs, over mitered elbow and tabs, and then draw it this way. So this curve there, I'm there do. And then I add a T here. I add a T here. It will put a different fitting there for me. As you can see, this is a fitting. You understand? So, which means that there are so many different fittings. And the point I want to make is that the type of fitting that is available to you will determine the type of pipe that you can draw. If you want to create any duct, any pipe, any conduit, or any cable tray, look at this cable tray. I can add create similar from the middle here and then join it this way. You see that Revit will automatically add a fitting to it for me. Thank you. And if you look at the fitting, by the settings within the software, there's this fitting here called M ladder horizontal T. If I want it bent at an angle of 90, create similar, I'll connect it to the end here, draw it at an angle of 90. I'm using 90 for now. I'll explore different angles later on. It will also add another bend here for the cable tray. And if I select this fitting, it also has a name. It is called horizontal bend fitting. As simple as that. So the point I'm trying to make is that any pipe, any duct, any conduit, or any cable tray is defined by fittings. If you do not define the appropriate fitting, then you can't draw it. You always get an error. Let me explain what I mean. Let me start a new project. File, new project. This time around, I'll not use metric multidiscipline. I'll browse. And then go to English folder, change the views to lists, and then choose, let's say, normal default metric folder, default metric, and then open. It's also another template. Then I'll go to OK. So this one will create another new file for me altogether. Then I'll go to the 3D view. Then within the 3D view, I'll go to systems and create, let's say, a duct. I'll just draw my duct here. Okay, it's drawn. As soon as I try to add a fitting here to this one and draw it, I'll get a warning. I want you to see the warning. So I'll go to zoom, magnify. The warning is down here. It's saying that the routing solution failed because there is no default fitting type specified, or the fitting cannot be found in the project. ensure that the fitting is loaded in the project and try again. So the point I'm making is that before you can draw any system element, being pipe, being duct, being conduit or cable trail, then you must make sure that the appropriate fitting is loaded within the project before you can use it. And the kind of fitting that you are going to load into the project is defined by the kind of system you want to create. If you want to create a hot water supply system, the fittings are totally different from if you want to create a cold water ducting system. It's also totally different from what do I call it? A cable trail. And it's also different from what? Electrical what? Conduit. So always, before you create any duct, before you create any pipe, before you create any conduit, before you create anything in services, MEP area, then the kind of fittings you are going to use must concern you very, very well. If you don't load the right fittings and route them appropriately, then it means you get a lot of wahala along your way. That's the point I want to make. Any question? Mr. Godwin,
Yes, my guy.
are you okay?
Yeah.
I think you are the only services engineer among us.
Yeah.
Can you throw more light on this fitting issue for us?
Okay. What would you want me to elaborate on?
On fittings, let's say if you are designing a system, let's take for instance any system, either cold water or hot water supply or whatever. What kind of fittings do you look out for in a particular system that you are designing? For instance, if I'm doing PVC or I'm doing PPR or I'm doing cast iron or I'm doing metallic something, what fittings do we normally work with, maybe within the Ghanaian industry?
Okay, so what you have already actually educated us on, that's how it is. PVC is a type of pipe. For cold water, you also have the PVC type of pipe for cold water. We also have PPR. For hot water, we have PPR, we have PVC, we have copper. So basically, Revit has already provided these options for you. You just select the type of pipe you want to load. So once you load it, Revit gives you the standard fittings that comes with it. From what I've realized, that's a good thing about Revit. It gives you what is required for the type of pipe you select.
Okay, thank you very much.
Okay.
Now let me close this file and go back to the other file that we are working on. There's one thing I want you to note. Any pipe you are drawing, any duct you are drawing, any conduit you are drawing, any cable tray you are drawing, I want you to see it as a 3D polyline. I repeat, as a 3-dimensional polyline. What it means is that if I take this pipe, create similar, I can start from A, move to B. When I get to B, I can turn and then draw. I can turn and draw. I can turn and draw. I can go back and draw. It is a continuous pipe that I am drawing. I define the path of my pipe. each unit or each segment will have a defined length or width. But you do the settings for the fittings once. When the right settings for the fittings are done, I'm going to show you later on, but today we're only doing the introductory aspects. If the right fittings are assigned to the pipe, then you can draw it anyhow. Any pipe that you draw can have an elevation. Currently, this pipe that I just drew has an elevation of 300. So if I right click and say create similar, watch. If I start from here at this point here, the elevation will be 300. So I can continue with the same elevation. But I can let this pipe rise by changing the elevation from 300 to say 900. As soon as I change the elevation, Revit will automatically add a rise pipe to it. And if I continue, you realize that, excuse me, you realize that this pipe will rise up. And when you select this pipe, you notice that the elevation of it is what? 900, as you can see. If I want it to drop, I can let it drop. If I want it to rise, I can let it rise. Whether I'm drawing it in plan or in section, I must be very sure of the elevation of my pipe. When I finish drawing it, I can change the elevation. When I finish drawing it, I can change the elevation of the pipe also by going to the properties and then changing the elevation from 900 to 1002 or from 900 to 1008. That's the middle elevation. And to just update. Now, if I select this pipe here, the current elevation of this pipe is 1008. If I right click and create similar, start from the end here, 1008. I'll just continue at the 1008. If I want it to drop below 1008 to say 0, I'll come in here, change the elevation to 0, enter. The pipe will automatically drop to the elevation 0. Then I can continue drawing my pipe wherever I want. Every pipe that you draw has its own elevation. So if you look at this pipe that I just worked on, it started from 300, bent, got here, raised it to 1008, went there, came here, dropped it to 0, and then moved on. This is the main principle and concept behind mechanical, electrical, and plumbing drawings. Any duct you draw, you must be very, very sure of the elevation of that duct, of that pipe, of that conduit, of that cable tray relative to a specific level. Any question?
No, please.
Sir,
Yes, sir.
so I want to ask the duct. What is it? Can you tell what it's used for? And the cable trail, what is it used for?
When you are doing air conditioning for a building, air conditioning, that's where we use duct. For instance, if you are doing a multi-story building and you want to supply air conditioning to all the rooms, and you want to do, let's say, central, normally we have the central air conditioning system, then we have the local air conditioning system. If you want to do central air conditioning system, you have one equipment, very heavy duty mechanical equipment somewhere that will create the chilled water supply. And that will supply the chilled water to all the rooms in the building. So the duct is the conduit, is the gateway, is the route through which the chilled water will pass through and supply all the spaces. If you go to the big hotels in Accra, like let's say Kempinski Hotel, they use those systems, those pipes to do them. Normally, if you take normal residential scheme and hotels, we use local systems with the outdoor units and then just connect it to the indoor unit by local connection. But if you want to use a central condition system, that is where we use the ducts to create them. When it comes to the cable tray, when you are working on a building that is big, there are a lot of cables that pass through the building in different places, different types of cables, some for power, some for communication, some for lighting, some for surveillance, some for sound, so many different types of cables. I'll show you drawings later on. What happens is that you need to know where these cables normally pass. But it's unfortunate in our part of the world, when we are doing a project, we don't do these drawings. We only go to the site and then the electrical people will come there and start chiseling where they want and where they want to pass the cable, which is totally wrong, which is very unacceptable. But under normal circumstances, somebody must provide these electricians the drawings that they need to work on and where they should pass their cables, where they should pass their pipes. I've been to sites whereby they've done electricals and they've done the screening, they've laid the pipes and everything. And then the building developed a fault. And there's a need for us to track even the pipes and then track even the path of the pipe. I've seen artisans chiseling floors, chiseling ceilings haphazardly, just because they don't even know where their pipes, their cables, and conduits are even passing. But if you are doing things and then you want to do it right, you can tell them exactly where these pipes should pass, so that as a professional electrical engineer, you give them proper mapping so you can go and point specifically here that chisel here, you get this, chisel there, you get that. But because we don't produce drawings, we just do things by heart in this country. This is something we must fight against. Are you okay? Me?
Sir,
Is your question answered?
yes, sir.
Thank you.
So that means the cable trail,
Uh-huh.
we use pipe to pass through it.
Yes, sir.
On
You lay
top
pipe
of
in
it.
there. On top of it, yes, sir.
You lay pipe on it.
Yes, yes, sir.
So I want to ask a question.
Okay.
When you're doing like 2 or 3 story,
Mm-hmm.
At the back of where the pipes, toilets and the bathroom are,
Mm-hmm.
the small hole that you leave and use 4 inches pipe and everything to pass through.
Mm-hmm.
What's the name of that?
It's called
It's also called that.
It's called a duct, yes.
It's also called that.
Yes.
And this one is called that.
Yes.
Okay.
No,
And that this one is for air conditioning.
Yeah, this
the
one.
The one that I mentioned is for PVC pipes and water supply and everything.
Yes, sir.
Okay.
Yes, sir.
I hear.
Now you see, a duct normally is means a path that you can pass something through there, technically. So if you want to do a building and you want to do the building nice, in order not to pass the pipes in front of the building haphazardly, you normally define a duct and then cover the duct with some metal grill so that you can pass all your pipes and stuff through there. So that if you want to work on them, you open it and then work there. Basically, those are the ducts in buildings. But when it comes to the air conditioning in a building, we draw, give me a minute. Let me not go far. Give me 1 minute. Go to File, Open. Then let me open a sample project to show you something. File, Open. And then go to Sample Files. And within the sample files, let me look for HVAC. And then open it. I want you to have a fair idea of where we are heading towards. The file is heavy, but Obi, let's give it some few minutes. And this weather is bad. This is the cover page. This is the title block and then the project. If you zoom in, this is just the cover page, showing you the building and then the duct. But let me go to the 3D view of it. Charlie, the boy is not feeling well. My machine is a very powerful machine, but still, you see, the software is, the machine is still struggling to open the file. Revit requires very good machines to work with, not your 16 gig RAM and 32 gig RAM machines. No. It doesn't help. Okay, so let me zoom in. You see, this project, the architecture file is in, the structural file is in. So let me hide some of them for now. So there are so many files here. So I'll go to links. Manage links. And then I'll go to, these are all link files. Them. I can unload the architecture. The architecture is loaded. How do I unload? Okay, so I'll select all of them for now. And then unload. Okay, so I'm unloading all the architecture files. The electrical, the sites, the facade, the structure. I want to unload all of them. Okay, and then leave only the mechanical. Good. Now, when you come in here, this is the mechanical drawing. So now you see that now it's lighter. Some come in the colors of red, some come in green, some come in purple. You see that there are some equipment in the ceilings, as you can see. And then the pipes are connected to them. So you connect the pipes, direct the path where to go, where it is going, then come all the way and then terminate here. If you look at this one, for instance, it starts from here, it will bend, it will come here, drop down, go here, bend, come here, right above here, go here, drop here, and then terminate at this point here. If you come in here, you see this one here. This is where the air is supplied into the room. So this is a vent. This is another vent. This is another vent. There are vents on both sides. But before the vent will come, this is this equipment here. If you take this equipment, then to supply the air from here through this pipe, then to come in here, go there, supply air here, supply here, through vent, then to come all the way through this path here to the end here, and can supply pipes, all the spaces, coming from this same word, equipment. Then we have the exhaust. Wherever there's any heat in the room, it will take the heat, take it out through this pipe, and extend it to an external point whereby you can work with. Basically, this is something that I'm talking about. There are different equipment in the building that supply different spaces with either hot air or with what? Cold air. So depending upon where you are placing the equipment, you need to be able to draw your duct through a path that will be convenient so that you can supply it to the appropriate space where it needs to be supplied. Are you okay? Are we? Please don't be confused with the drawing you are looking at.
Yeah, it's actually confusing.
Yes,
It's actually confusing.
initially, it can be very, very confusing. It can be very, very intimidating, I must confess. But don't panic. Let me just take one of them. Give me a minute. Give me 1 minute, I'm coming. I want to take just one of the systems. So I'll come in here, hover over it, and then tab. Tab again. Then go to isolate. Isolate isolate elements. So I've hidden everything and left only one of the system. So this is the equipment, and this equipment is called heat recovery unit, mechanical equipment heat recovery unit, HRE. This heat recovery unit takes heat from the room through this one and then brings in cold water through this one. So when you hover over each one of them, it's a duct. This one is a duct. This one is also a duct. This one is also what? A duct. But each one of them performs a different function. Please, if you are not a mechanical engineer, you might not understand the language that I'm speaking here. But if you are a building industry professional, I'm choosing my words carefully. If you are a building industry professional and you want to understand the whole building system, what it means is that you must understand the architecture system, you must understand the structural system, you must understand the mechanical, the electrical, and plumbing. You must have a fair idea so that you can know how to coordinate buildings on site. But unfortunately, in our part of the world, we have reduced building to block work and concrete only, and then plastering. We don't think of systems. We don't think of anything. We just put up the buildings and we are there. But if you want to create a public building, a building that is big, and you want the building to be comfortable for people to live in that building, you cannot ignore building services. You must understand what building services, and you must know how to work with building services engineers in order to be able to create whatever you want to create. So if you don't understand the building services system, don't force yourself to understand. But I want you to assume and pretend that, okay, there is something like building services. So this is how it goes about. How we bring in cold air, how we bring in hot air, how we take, for instance, you might not know, you can get a hospital project. And the hospital project, you need an intensive care unit, you need surgical unit, you need that, you need that. You need to supply a lot of air and gases and liquids to the various rooms to be able to take care of patients. In that case, you must be in a position to produce drawings that will allow you to supply all these elements to the various spaces in the hospital. You might not know. You might get a job on one of these oil fields in the Western region. And whereby you are on the oil field, you might be expected or required to draw pipes and the petroleum piping drawings and all those things. These are all job opportunities that if you master building systems, then you can venture into. So let us not limit ourselves. Let us start slowly and then get to where you want to get to. Let me go back to reset, temporary or height isolate and show you something about electrical also. So you get a picture of where we are getting to. Maybe I might see cable tray. I'll go here, go to electrical, reload. When it reloads, I'll remove the mechanical from it. Okay, that's the electrical load there. So I'll go to the Where's the mechanical? Structural, plumbing, facade, electrical. I open the mechanical. So let me just unload. That's the main mechanical. But rather, let me take the electrical and open rather. I'm just opening the electrical drawing only. I want all of you to re-engineer your minds how you see buildings. Take note. Buildings that you need to work on with Revit, most of the time tends to be very complex buildings. Not 2-bedroom house, not 3-bedroom house. So if you are using Revit to deliver on a 2-bedroom house and you let it seem like a job for you, please recondition your mind. There's a lot of things that we need to do and a lot of things that we need to learn. Take note of that. So this is the electrical file. Open and manage links. I'll take everything, shift to that, and then unload. I want to only look at the electrical. Okay. So it will unload everything. And then we look at the electrical only. So, I'll close it and then go to 3D. I normally want to work in 3D because 2D views are just a representational. 3D view gives the written. So this is the electrical drawing. If you look at the electrical, you see lights, you see conduits. Let me change it to fine. These are conduits whereby we pass our pipes and cables through them. You see cable trays. You see the pipes, the conduit pipes. You see the way they are directed and they move through the building. All the way they come here, they drop down to different electrical equipment. This one is called a wiring pool box. All the wiring, they come and pass them to one particular location and then position them and then add them. So to be able to draw these conduits, then you must be able to understand how drawing conduit works before you can attempt such a project. If you don't know how to draw conduits, if you don't know how to draw cable trays, if you don't know how to draw the different aspects of the building, then working on such a project might be very, very difficult for you. For instance, if I'm supposed to travel outside Ghana and then go to UK and then enter any architecture, engineering, or construction office and tell them, I am a Revit user. I want to come and work with you. I know how to use Revit. The question they'll ask me is that, can you do electrical drawing? Then I'll say yes. Then they'll give me a drawing like this to do for them. And I bet you I can deliver it for them. But if you cannot deliver it for them, then it means that you don't know what you are about in the first place. And it's unfortunate in our part of the world here, let me use Ghana because that's where I've grown. We still do drawings in 2-dimensional layout for services drawing. All electrical drawings are done in 2-dimensional. All mechanical drawings are done in 2-dimensional. All plumbing drawings are done in 2-dimensional using a colloquial tool like AutoCAD. How can you use AutoCAD to deliver such a project? At the end of the day, when you go to the field, the challenges you face on the field are totally different from what you do in the drawing room. But Revit presents an opportunity for us to be able to model the building realistically so that you know where your cables are passing, you know where your conduits are passing, you know where your ducts are passing. So now I can decide to, within this building, connect the HVAC to it. So I'll right click and then go to reload. When I reload, it is going to, I think I've opened the HVAC. Let me close it, I'm coming. This HVAC, let me close it here. Okay, save changes, no. And then come back to this electrical and then take the HVAC and then choose reload. As soon as I choose reload to this one, what will happen is that I can see where the pipes are passing, where the cable trays are passing, where everything is passing. And then if there are any clashes or anything, I can see them and correct the clashes using a tool called clash detection before we even go to the field. But currently, our modus of operandi and the way we work in our part of the world, it doesn't permit us to do some of these things. So we only go to the site only to face the challenges on the site. So a building that is supposed to cost 50 million Ghana cedis, by the time we are finished, we have to do variations, and the building will cost us about 100 or 150 million Ghana cedis. Not because of anything, but it's sheer because of our ignorance of the tools that we need to use to deliver the project successfully. Are you okay? Antoinette?
Sir,
Do you get a picture I'm painting?
yes.
Thank you. Mr. Kuonu,
Mankind.
do you get a picture I'm painting?
Yeah, I'm following.
Thank you. So the point is, if you want to be able to work on a complex building project that can change your lifestyle, please, we need to reorient our mind and look at our project delivery methods. Our current way of working, whereby we work in 2 dimensions, in architecture, 2 dimensions, in structures, using AutoCAD to do structural drawing, AutoCAD 2-dimensional work to do structural drawing, AutoCAD 2-dimensional work to do mechanical drawing, AutoCAD 2-dimensional drawings to do electrical drawings. It's a cake. It's a cake. It can't take you anywhere. Now, if you are doing 2-dimensional, then it means that you cannot even do 3D. And if you can't do 3D, how can you do 4D? How can you do 5D? How can you do 6D, 7D, 8D, 9D? So if we are not discussing these topics at this level, and we are still stuck to the 2D mindset, please, we are leaving behind about 20 years in reality. So what happens is that if there is any good project, if there is any complex project that is supposed to be built in this country, then we have to outsource it to foreigners for them to do the work for us. Not because they are good engineers than us, not because they are good architects than us, but the truth of the matter is that we have failed to invest in the technologies that we can adopt for us to remain relevant in the industry. I happen to get the opportunity to have worked on several projects in Ghana. I worked on the West Coast Mall. I worked on the EcoBank head office. I worked on the ADB Car Bank head office. I worked on the Advantage Place Enterprise Properties Limited new head office building. I worked on the 34 Port Complex building in Accra. And please, I am telling you, if you do not up our game, you will see juicy jobs being taken away from us. The minimum requirements to survive in the AC industry now is being able to model any building system 3-dimensionally so that you can use it to do 4D, 5D, 6D, 7D. That is the topic we call BIM, Building Information Modeling. And if you cannot do three-dimensional model of a complete building system, then how do you do 4D? How do you do 5D? How do you do 6D? How do you do 7D? So please, I'm going to close this file. All of you, if you go to your machine, go to the file, go to open, scroll down, you will see sample files there. Go and explore the samples file folder. There are samples for architecture, samples for electrical, samples for facade, samples for HVAC, samples for plumbing, samples for site, samples for structures. Please, I have studied all these samples files for Revit since the year 2009. I have. And I know what it can do, and I know what you can achieve with it. Take your time and explore. Nobody will do them for you if you don't push yourself. So in reality, the point I'm trying to make is that if you go to these drawings, there are plan views. For instance, if you go to lighting or power, let me go to the sheet. Okay, you let me go to sheet. There's a power plan, level 1, for instance. They've done a power plan here. Let me link everything together, all the links, so you can see the link where. Links. Manage link. Select all of them. Reload. All of them will be reloaded. Operation in progress. Please, we have a lot of things to learn. Let us up our game. I started Revit training in 2009, and I had to abandon the project in 2014 because what I realized was that we were not ready to learn. So the essential training that I did between 2009 and 2014, that has become the national standard. Nobody added on. Nobody, I repeat, nobody added on. And we still use Revit on the surface. So if you come here, this is a power plant. Look at the drawings. Well documented. Everything is in there, from plumbing, power units, sockets, everything well documented. Well presented. If I go to level 2, this is level 2, well documented. And I am telling you on authority, we can, with the right application of knowledge, we can even do better than this one. There are schedule sheets that they've done, different schedules, branch panel, ADP. It shows you the location, it shows you the supply, it shows you the mountain, the enclosure, it gives you circuit description and everything. And if you understand electricals, this is something you can do. But if you don't understand electricals, you see it like Arabic. Switchboard and meter banks. There's a sheet for switchboard. And these are all generated reports. It is not line work that anybody did. These are schedules that were generated and placed on the sheet. And if I make any changes anywhere, everything is updated within the world, within the drawing. We have appliance dwelling unit, load classification, HVAC, lighting, receptacles, power, all of them, connected loads. All the calculations are done for you. The demand factors are done. Estimated demands are done. Everything is done for you. Now, you need to revise your notes. And please, to my architectural technology students, take note. You don't know which office you are going to find yourself in after school. You don't know where an opportunity is going to present itself to you after school. You might land in an architecture office. You might land in a structural engineering office. You might land in a services engineering office, mechanical, electrical, plumbing. So you have to open your mind. Even if you don't understand the system, know how to model them so that under an instruction of an experienced engineer, you can take an instruction from an experienced engineer and then model for them what they expect you to be able to model, and it can take you to places. Let me close this file because if I want to continue talking, we won't get anywhere. You come back to it later on and then go back to our file that we are working on. Save changes, no. Now, the whole idea is that before you can produce such a drawing that I showed you, then you must understand how you can draw your pipes and how you can connect them. So let me take a pipe, for instance, from here. Create similar. I can take a bigger pipe, diameter of, say, 200, and I start drawing of length, let's say, 1,001. As soon as I finish, I can change the diameter to, say, 100. As soon as I change the diameter, Revit will automatically add the reducer to it for me. So you can see the reducer is added. When I finish and I change the diameter to, let's say, another 200, and I continue from here, it will add another reducer to it automatically for me. When I bend it at 45 degrees, it will add an object to it. I can rise it to a level, the elevation, I can increase the elevation to, say, 1,200. Okay, then to rise, then I can continue drawing. So if you look at it, I am modeling a pipe in a 3-dimensional form. This is what I want you to understand in the first place before anything. Before we can even discuss how to design systems and how to do anything, you must know how to draw the pipes. In the first place, you must know how to draw the ducts. In the first place, you must know how to draw the cable trays. In the first place, you must know how to draw the conduit. In the first place, if you cannot draw them, then there's no way you can work with anything. If I'm doing air conditioning, I can take my air conditioning here, create similar. Then let me draw an air conditioning here. Bingo is here. When I finish, I can change the size from 300 by 300 to, let's say, 200 by, let's say, 150, different size, 200 by 150. Then I can connect it here and then draw it to the side. I'm coming. I'm getting an error because the routing solution failed because there's no default fitting type specified or whatever. So, which means that this one, the fitting is not properly defined. So that's why I'm getting an error. But let me connect it to the back and see here too. I'm still getting an error. And to do that, I'll not discuss it today. I'll discuss it tomorrow. Before you can work with any pipe properly, any duct properly, any cable tray properly, you select it, you go to edit type. Then when you go to edit type, there's something we call routing preferences. Let me maximize it and show you. Maximize. There's something we call fittings routing preferences. And when you go to the fitting routing preferences, you can go to edit. And when you come to the edit, you see that elbow is none. Preferred junction type is T. Junction is none. Cross is none. Transition is none. Multi-shape transition rectangle to round is none. So if you don't do these settings correct for the duct, then there's no way you can draw your duct in any way. So you must understand this routing preferences dialog box and do the appropriate settings before you can draw any pipe or any duct or whatever. Let me check that on the PVC and watch something. Let me go to PVC, the one we are working with here. And then edit type. The same way, we have the same routing preferences. Where's my magnifier? You have the same routing preferences for the PVC. Now, if I click on edit type, you see that there are definitions for there are definitions for the pipe segments, the minimum size, the maximum size. The elbow is M-bend PVC, schedule 40. The preferred junction type is T. You can either do T or tap. The junction is what? MT sanitary PVC. There's a cross none. So the cross is none, which means that if I don't add a cross and I want to create a cross within the pipes, I'll get an error. There's a transition, that's a reducer. Then there's a union, there's a flange, there are caps. So you need to set all these things before you can draw the pipes. If you get your routing preferences wrong, there's no way you can draw a pipe, you can draw a cable trail, you can draw anything. If I select the cable tray also, close this one, close that one, then let me minimize this thing again. Minimize. Take the cable tray also, this one, and I select it, and then go to edit type again. If I go to edit type, the same thing is here. The fittings that you need to use for the cable tray is also here. Fittings, horizontal bend, vertical inside bend, vertical outside bend, T, cross, transition, union. And you need to load, excuse me to say, all the libraries that is required. In a future date, if you become a master Revit user, you might not even be using this, the default metric one, because they are very basic. There are industry standards. There are manufacturer specified fittings that you can load and then use them, and not to depend upon this one. So this ones you can use to do LOD 200 drawings. But if you want to do LOD 400 drawings, then it means that you need to get realistic fittings to do the job. If you want to show PVC fittings, you can get proper PVC fittings, you can get proper PPR fittings, you can get proper copper fittings, you can get proper anything to do the model. So take note of that one. But you look at it tomorrow, not today. But for today, my concern is your ability to draw a pipe, your ability to draw a duct, your ability to draw anything. So if I take this duct and I want to create a bend to it, I can create similar, go to a bend, and then create my bend, and a bend to be added. I can go this way. If I want to rise, I'll increase the elevation from 1,002 to 1,800. Good. Then to raise, then I'll continue drawing my pipe. If I want to rise again, I can increase it from 1,008 to 2,400. Then continue. I make it 2,400. 2,400. Then I can continue from here. I can turn here. If I want to drop down, I can increase it, drop it to 600 down. Then to drop down automatically. Then I can draw it here. I can go this way, anything. That is the point I want to make. Be able to draw it. It's a polyline you are drawing. Get that concept. You might not get it today. You might not get it tomorrow. You might not even get it by Thursday when we meet again. But you need to make a conscious effort that you will get it in the medium to the long term. So this is what I want you to understand, that you can draw these things and you can size them. You can reduce their sizes. You can increase the sizes. You can do whatever you want. So I can take in any pipe here. I can add a joint to it, create similar in 3D. You can also do it in 2D, but never worry, never mind. You can bend it at an angle. When I finish, I can thread this fitting here. Okay, add another joint to it. It will update the fitting. I can right click here, right click on this one, draw pipe. Then I can continue drawing my pipe as I want. When I get to a certain point, then I want to make the pipe bigger. I can increase the diameter of the pipe. If I want to make the pipe smaller, I can increase the size of the pipe to say, I can decrease it to say about 50, then to decrease. Then I can draw my pipe. Then I can bend it. I can do anything. Any question? Mr. Godwin,
That's my kind.
any question?
No, I'm fine.
Okay. BC.
Mankind,
BC.
that's my PC. It's my PC.
Okay, are you okay? Gary?
Yeah, yeah,
Are you okay?
yeah,
Okay.
yeah.
Rohi? Rohi? Hello, Rohi? Mrs. Dake? Mrs. Dake? Dixon?
Yes, sir.
Are you okay?
I'm okay, but it's a little bit complex.
Come again. Yes, it's complex, but let's fine tune our mind. Let me give you a scenario. Let's take a simple two-bedroom residential scheme. Okay. There's a two-bedroom, there's a kitchen, there's a bathroom with a shower, a WC, and then a sink. Let me put it that way. They want to do plumbing for that particular building. It's a simple building. First, you need to bring in water into the house. So you must connect the main water pipe from the main Ghana Water Company line. They use that black pipe. Please, that black pipe, how do you call it, Mr. Engineer?
You mean the soil pipe?
The pipe that the water company people use to tap the water from the main lines into the house. The black one.
HDP.
It's HDP. So you bring in the main water from the HDP, from the main line to your meter, where your meter will be. Then from your meter, you are going to use other pipes to connect from the meter, whether you're going to use PPR, whether you're going to use PVC, whether you're going to use whatever pipe, I don't know. That one is at the discretion of the engineer who is working on it, or the person who is in charge of the project, or the plumber who will be in charge of the project. And if you are a building industry professional, then you leave such a critical aspect of your building in the hands of a plumbing artisan, which is something we do in this country. Then it means we are heading for trouble. You understand what I'm saying? Actually, you should get an engineer who knows the right pipes to use where and when. So that as soon as you connect from the meter, okay, what pipe size do I need to connect from the meter from the main pipe to the kitchen? When I get to the kitchen area, how do I connect my pipe to the kitchen? From the kitchen, I need to extend the pipe to the bathroom area. How do I bring the pipe from the external inside the bathroom, connect it to the shower, connect to the wash hand basin, connect it to the WC, so the WC can get power, it can get wash hand basin. These are things that are very basic for a small residential scheme that we are going to work on. And I'm going to demonstrate it on the project that we are working on. But at the end of the day, I must be able to draw the pipes and connect them for my small building scheme. If I can do it for a small building scheme, then I should be able to do it for a story building. And if I can do it for a story building, then I should be able to do it for a hotel. And if I can do it for a hotel, then I must be in a position to do it for a hospital. And if you are doing a hospital project or you are doing a residential scheme project, note that the piping requirements are totally what? Different. You must have some level of understanding of piping before you can do such a drawing. And you cannot leave such a scheme in the hands of an artisan, excuse me to say. We cannot leave such a scheme in the hands of an artisan. So before I will hand over a project to the artisan, I can model all the pipes, schedule all the pipes, tag all the pipes, give them numbers, give them codes, and manufacture all the pipes, cut them into sizes, give them individual codes, then just send them to the site and then give it to the artisan, only for the artisan to assemble. But if I am going to leave an artisan on site to decide the length of pipe, the length of bends, the type of bends, and whatever to do, then it is a serious crime I'll be committing to my clients. Do I make myself clear? It's a bitter pill we need to consume, but I need to say it the way I should say it. This is the way forward for us. So if Gary,
All right, sir.
Gary,
Yeah, okay.
you are an architect. Excuse me to
Yes.
say. And you are working on a hotel project. And you know how to use a tool like Revit. And you know that with Revit, you can coordinate and check all your pipes, pipe sizes, scheduling, everything. We've not come to the pipe fitting, so between these pipes, there can be several fittings. There can be valves, there can be meters, there can be so many fittings, there can be tabs, there can be accessories that you need to connect it to the different areas. And you can model all of that. You can schedule all of that. You can put a cost value to all of them. So at the end of the day, you can give the client a very, very realistic value to the project. But if you have a tool like Revit, then you don't produce those drawings, you don't do all those things, then you expect an artisan to go to the site and then go and do an estimate, not an estimate, to go and do a guesstimate. And I come and present to you, Master, we need this number of pipes, so we need this number of fittings, so we need this, so we need this, so. Then it means that you will be exposing your ignorance to the client. And excuse me to say, that is what we do in this country. We don't care. We just do not care. So if you want to be relevant in the industry, in this IT era, then we must reorient our mind. We must reorient the way we look at things. And then change the way we work, our workflow, so that we can make the kind of impact we need to be able to make. But if you don't reorient our minds and change our workflow and work the way we are supposed to work and see architectural technologies even as a threat to our kind of work that we are doing, then it means we are not heading anywhere. I see some architects complaining. I see architects complaining that a draftsman is taking their job for them. Then what kind of architect are you? Let's take note. Today, I am only looking at the fact that you can draw pipes, you can draw ducts, you can draw conduits, and you can draw cable trays. These are the major things that we need to do. When we come tomorrow, we will look at fixtures. So I can go into say system, go to plumbing, and then click plumbing fixture. Then when I click on plumbing fixture, I can pick, let's say, water closet, and bring in my water closet. Now, when I bring this water closet, You see, there are two endpoints. This is an endpoint here. Then this is another endpoint here. The one at the top here is for water supply into the WC system, which you can use to flush. The one at the endpoint here is the wastewater line. So when you flush the WC, it will go. If I go to the side like this of this WC, I can right click, draw pipe, and then I'll draw a pipe. Currently, it has given me elevation. So I need to specify the elevation down. So let me go to negative, say, 600. So the pipe will come down by negative 600. Do you understand what I'm saying? Then, then I can draw the pipe. Do you get the point I'm making? If I select this one here for the main water supply, I can right click, draw pipe. Then I can draw a pipe on it. I see I'm doing it on orthographic. That's why I'm getting an issue. Let me go to 3D isometric. Give me a minute. Let me take this one, right click, draw pipe. So I'll give it an offset. Middle elevation, negative 600. Then I can go this way. Then the pipe will be drawn. Now, if I go to the side and I select this one, it's negative 600. So if I want the pipe to come up, this negative 600, I can use even the arrow key and then move it up. Or I can type the exact value how I want it to drop. I want it to drop by, say, negative 300, which I can type, negative, say, 300. Just below the slab, negative 300, just below the slab. So I can do this way. So I can see the pipe I am bringing here. I can see the bend I'm adding. I can see the pipe that I'm bringing outside. When I go to another 3D again, I can select this pipe here from the back. Here, right click, draw pipe. Then I'll bring the pipe outside small. Then I'll bend it here by say 90 degrees. Then I'll let it drop down by say another negative 1,200. Then the pipe will go down. Then I'll draw it that this way. So if I look at this and I select them, it's just demonstration, okay? And I look at it a bit. I can see how the pipes are connected. I can see how the waste pipe is connected. I can see how the water pipe is connected. And I must know where this pipe is coming from before I can pull it anywhere I want to pull it. I can pass it through walls. I can pass it through anything. But the whole idea is that I should be able to know the routing path of the pipe, where it is passing and coming before it is connected to this WC at the end of the day. And this shouldn't be very difficult for us. If a plumbing technician or a plumbing artisan can do it on a site, please, I beg, I challenge all of you, whether you are a draftsman or whether you are an architectural technologist or whether you are an engineer or whether you are an architect, I challenge all of you, let's sit up. Let's shaping our mind. Let's reorient our mind that we need to be able to master these tools and then use them well. Please, I started this training in 2009. No services engineer expressed interest. No structural engineer expressed interest. It's only architects who express interest in the Revit. And the architects who are using Revit to, excuse me to say, they are using Revit at the children's swimming pool level. Meanwhile, we are supposed to go to the sea and ship for a shark. Meanwhile, we are swimming in children's swimming pool. How can we make it? How can we survive in the system? We can't. Let's take note of it. And you can do it and model it the way you want it and make it neat work, and you can do anything that you want to do and you can achieve anything with it. Any question? If I want to bring in a sink, I can go into components, plumbing fixture, go in and then look for sink. Sink. So there's a sink here. This sink might be hosted by something. I don't have a wall or something. let me take a different sink. Okay, this is another sink. So when I bring this sink into, there's a wastewater pipe. This is a very basic sink. This is a generic sink, so you cannot use this sink. But you can get proper manufacturer specific sink and then load it. And when you load it, you can connect a waste pipe to it and then draw the waste pipe and then do whatever that you want to do to it. We'll look at that one tomorrow. Any question? Godwin,
No, it's Michael. Michael.
I'm talking. I want to talk to Godwin. He's a service engineer.
Ah, okay.
I'm here.
Your remarks, concluding remarks before we go. What we discussed so far.
In terms of what we have done today,
Yes, sir.
what I can say is that the Revit actually simplifies things for you if you know what you are doing. So once you are able to determine the type of pipe you want and you put in the fittings, the right fittings that's associated with the pipes, I mean, it simplifies your work for you. So it's a good tool, honestly. It's a good tool. If we can learn to use it, it will really help. It will help in terms of shortening the time we spend in drafting or drawing or designing. Yeah, thank you.
Thank you, Godwin. Gary,
Yeah, okay.
what do you say?
Oh, me, I wanted to ask something. You see, when you were drawing the pipes without any plumbing fixtures, they were all coming the same color. But when you put the WC and then we linked a pipe from the waste end and then a pipe from the supply end, the waste end changed to green. And the supply end is blue. So I'm assuming when you are drawing a waste pipe, that is what is going to come.
You can edit the color to any color you want.
You can edit the color.
Yes.
Okay. Sure.
You can edit any color you want. Let me show you something small. If you go to view menu here, then you go to user interface here. There is something we call system browser. System browser.
Yeah.
So I open it. Now, when it comes to the system browser, you see we have unassigned system. We have mechanical systems. We have piping systems. Then we have electrical systems. So if you take piping, for instance, you can have domestic cold water system. You can have sanitary system. You understand? There are different systems for piping. So depending upon the kind of project that you are working on, and then the kind of system that you create, you can give color codes to different systems. You can give color codes to different fixtures and fittings. You can give color codes to anything to make the work more presentational. So when it comes to colors, it's a computer. And please, one thing I like about computers is that you can graphically manipulate anything that you see on your computer screen to look the way you want it to look, in terms of size, in terms of graphics, in terms of materials, in terms of anything. Are you okay?
Yes, yes.
Me? Class B. Hello, Mr. Nee. He's not around. Antoinette.
Sir,
What do you say?
I'm here.
The plumbing and then the mechanical pipes and the ducts and then the cable tray discussion. What do you say?
The drawings, maybe the only thing that will have a problem with is when they are crisscrossing each other, but the drawing I'm okay.
Okay. So when we get to where they are crossing each other, it will be addressed. Okay.
Okay.
Any challenge, I want to give you the assurance that any challenge that any of us will face, I promise the person that we can have solutions to them. Okay.
Yes, sir. Thank you.
You're welcome. Bagovi.
Yeah.
Any comment or contribution?
Nothing much. Ahmed has said it all. So,
Dixon. Dixon,
Please, I'm here.
what do you say?
I'm here. Oh, it's okay. Since it's the let's say the basics that we are building upon, so really we'll get it.
Okay. Rohi. Rohi. Dake. Rohi. I can't hear you. Are you speaking? Hello, Rohi. Rohi, are you having challenge with your Zoom? My voice is not going through and I don't understand. I don't know why. Okay. Okay. Okay, noted. Tomorrow, I'll talk to you later on after the class and see how we can resolve this one. Okay. If there's any question or no question, we can close for the day. Is there any question? If there's no further question, I suggest we close for the day and continue tomorrow.
Yeah.
When we come tomorrow, we will address the fact that we don't just draw pipes. We don't just draw ducts. Normally, the duct will start from somewhere. The pipe will start from somewhere and terminate at a point. So you look at a typical routing for a pipe. You place and few WCs, place and few sinks, place and few shower, place and few shower trays, add some floor drains to it, and see how best we can, in a small unit, and see how best we can draw them together and then get it properly done in a realistic manner. For today, my focus and my attention was just on how to draw them. So see you guys tomorrow at 8 o'clock. Thank you very much for your attention.
Right. Thank you.
See you tomorrow.
Sure.
So I'll save the file, save as project. Desktop, Revit session training, the lesson 11. Save. Okay. Stop. Stop. end.